Earth and Venus, two planets that began their stories as twins but evolved into drastically different worlds. At first glance, Venus appears remarkably similar to Earth. Both planets share nearly identical sizes, masses, and compositions. Venus even sits in a position close to Earth in our solar system, earning it the title of Earth's sister planet. But 4 billion years ago, something changed. While Earth became a thriving oasis of life, Venus transformed into one of the most extreme environments in our solar system. Evidence suggests Venus once had vast oceans of liquid water, and potentially even a climate similar to Earth's. Some scientists believe it might have been the first habitable planet in our solar system. But Venus's story is one of paradise lost, a cautionary tale of how a world can change beyond recognition. Today, Venus is a world of extremes. Its surface is hot enough to melt lead, with an atmosphere so thick it would crush a submarine. This radical transformation has puzzled scientists for decades. The key to this transformation lies in Venus's runaway greenhouse effect. Its atmosphere is 90 times thicker than Earth's, trapping heat in an ever-escalating cycle that turned the planet into what we see today. Recent studies suggest Venus might still be geologically active, with evidence of ongoing volcanic activity adding to its already extreme environment. Venus serves as both a mirror and a warning, showing us an alternate path that Earth might have taken, and perhaps still could. Understanding how Venus transformed from an Earth-like world into the inhospitable planet we see today has become one of the most crucial questions in planetary science. The answer could help us better understand our own planet's future. Welcome to Venus's metallic nightmare, where the laws of nature seem to bend in ways that challenge our earthbound imagination. At 462 degrees Celsius, Venus's surface temperature is hot enough to melt lead, zinc, and many other metals. For perspective, this is hotter than the self-cleaning cycle of your kitchen oven. Any spacecraft landing on Venus faces a daunting challenge. The Soviet Venera probes, the only human-made objects to reach the surface, lasted mere hours before succumbing to the extreme conditions. But perhaps the most bizarre feature of Venus's atmosphere isn't just its heat. It's what that heat does to metals. In the cooler upper atmosphere, metals like lead and bismuth actually vaporize from the surface and condense into a peculiar form of metallic snow, creating a weather cycle unlike anything on Earth. These metal compounds rise through convection, condensing at higher altitudes where temperatures drop to more modest levels, creating a unique precipitation cycle of metallic compounds. The atmospheric pressure on Venus's surface is a crushing 90 times that of Earth at sea level. Imagine the pressure nearly a kilometer below Earth's ocean surface. That's what you'd feel standing on Venus. This immense pressure creates an environment more similar to the depths of Earth's oceans than its surface atmosphere. The atmosphere is so dense that walking through Venus's surface atmosphere would feel more like swimming through a fluid than walking through air. The carbon dioxide atmosphere is laced with clouds of sulfuric acid. While Earth has its water cycle, Venus has a metal cycle. These metallic compounds form tiny particles, creating a constant metallic haze that adds to the planet's mysterious appearance. The combination of crushing pressure and extreme heat creates conditions so extreme that the horizon appears distorted through the super-dense atmosphere, creating an alien landscape that defies our earthly expectations. Now, let's explore one of Venus's most baffling features, its super-rotating atmosphere that defies the laws of planetary physics. While Venus itself takes 243 Earth days to complete one rotation, its upper atmosphere races around the planet in just 4 days, reaching speeds of 360 kilometers per hour. This creates a dramatic disconnect between the planet's surface and its sky. The phenomenon, known as superrotation, means that Venus's atmosphere moves 60 times faster than the planet itself. Imagine Earth's winds consistently moving at speeds faster than our strongest hurricanes, but across the entire planet. These extraordinary winds create something even more remarkable, a state of perpetual twilight across the planet. The super-rotating atmosphere, combined with Venus's thick sulfuric acid clouds, scatters sunlight so effectively that the surface exists in a constant state of orange-tinted twilight, about as bright as an overcast day on Earth. The rapid atmospheric circulation acts like a giant conveyor belt, distributing heat around the planet. This explains why Venus maintains nearly uniform temperatures between its day and night sides, unlike any other planet in our solar system. And here's something truly mind-bending. If you could stand on Venus's surface, the clouds would appear to move at walking speed. But those same clouds are actually whipping around the planet at speeds that would cross the continental United States in under an hour. Venus's atmosphere acts like a massive heat engine, powered by an endless cycle of solar energy and atmospheric motion. Recent observations have revealed massive bow-shaped structures in Venus's atmosphere, stretching from pole to pole. These atmospheric waves play a crucial role in maintaining the super-rotation, though their exact mechanism remains one of planetary science's biggest mysteries. By the way, if you're enjoying this deep dive into Venus's mysteries, hit that subscribe button. We'll be exploring more fascinating planetary phenomena in future videos, including upcoming Venus missions that might finally solve the super-rotation puzzle. The super-rotation creates a complex system of atmospheric circulation that scientists are still working to fully understand. It's a testament to how Venus continues to surprise us, challenging our models of how planetary atmospheres should behave. In a twist of scientific serendipity, the Parker Solar Probe's Venus flybys have revealed far more about our sister planet than anyone expected. While Parker's primary mission focuses on studying the Sun, its 7 Venus flybys have provided unprecedented close-up observations of the planet's upper atmosphere, detecting phenomena that previous missions missed entirely. During its third Venus flyby in July 2020, Parker detected something extraordinary, a natural radio signal coming from the planet's ionosphere, the first direct evidence that Venus's upper atmosphere physically changes when interacting with the solar cycle. These radio emissions, often described as Venus's version of Earth's northern lights, tell us that the planet's interaction with solar wind is far more dynamic than previously thought. Unlike Earth, Venus lacks a global magnetic field. Scientists expected this would make its interaction with solar wind relatively simple. Instead, Parker revealed a complex dance between the solar wind and Venus's induced magnetosphere. The probe discovered that Venus's ionosphere becomes significantly thinner on the night side, creating a long tail that stretches into space, much like a comet's tail. This suggests the solar wind is actively stripping away Venus's atmosphere. Parker's measurements revealed this tail contains heavy ions of oxygen and carbon, key components of Venus's atmosphere. This ongoing atmospheric loss might help explain how Venus transformed from a potentially habitable world into the extreme environment we see today. But the surprises didn't stop there. Parker's sensitive instruments unveiled features of Venus's upper atmosphere that had remained hidden for decades. The probe detected massive wave structures in the ionosphere, similar to Earth's atmospheric gravity waves, but on a much larger scale. These waves appear to play a crucial role in how energy from the solar wind is distributed throughout Venus's atmosphere. Perhaps most intriguingly, Parker observed that Venus's ionosphere behaves differently during solar maximum and minimum, suggesting the planet's entire upper atmosphere breathes in and out with the Sun's 11-year cycle. These observations have transformed our understanding of how planets without magnetic fields interact with their stars, with implications for understanding exoplanets around other stars. Our Hellish sister planet holds critical lessons for Earth's future, and scientists are racing to understand them. Venus's transformation from a potentially habitable world to an extreme greenhouse planet represents a worst-case scenario for Earth's climate future. Understanding how Venus crossed this threshold has become crucial for predicting Earth's climate tipping points. While Earth's greenhouse gas levels are nowhere near Venus's, studying Venus helps us identify early warning signs of runaway climate effects. Venus shows us how small changes in atmospheric composition can trigger cascading effects that transform an entire planet. Venus serves as Earth's future warning system, showing us planetary boundaries we must avoid crossing. Multiple space agencies are now racing to explore Venus. NASA's Da Vinci mission will plunge through the atmosphere, while Veritas will map the surface in unprecedented detail. The European Space Agency's Envision will peer beneath the clouds using radar. These missions are developing new technologies that not only help us understand Venus, but also improve our ability to monitor Earth's atmosphere. The extreme conditions on Venus push our engineering limits, leading to innovations in climate science. By studying Venus's history, scientists have identified several climate feedback loops that Earth must avoid. When oceans begin to evaporate more rapidly, water vapor acts as a greenhouse gas, creating a vicious cycle that can spiral out of control. Modern climate models now incorporate lessons learned from Venus. Understanding how Venus lost its oceans helps us protect Earth's water cycle. Every discovery about Venus's past refines our predictions about Earth's climate sensitivity. But Venus offers hope as well as warnings. Understanding how planets can change so dramatically helps us protect our own world. New missions to Venus will help us understand not just planetary evolution, but also the conditions that allow life to flourish. This knowledge is crucial as we search for habitable worlds beyond our solar system and work to preserve the habitability of our own planet. As we conclude our journey through Venus's extreme world, remember that this isn't just the story of another planet. It's a chapter in Earth's possible future, one we're now working to understand and prevent. Thank you for exploring Venus with us. Don't forget to subscribe for more deep dives into our fascinating solar system.